And usually when I teach this in the classroom, even though this is not going to be a part of your CCNA, I'm going to show you how to do from decimal to hex to binary, and from binary to hex to decimal, and all the different ways. But always remember, binary is the middle ground. Binary is the middle ground. Okay? Also, I'm only going to show you up to 255. That doesn't mean that you can't do larger numbers. Okay? And I'll show you at the very end. So for right now, so you can get the swing of things, we're going to do first from, numbers up to 255. Okay? First, let me explain what I got here on the board. Now, these numbers you see up here, all right, the 128, 64, 32, 16, 8, 4, didn't forget it this time, 2 and 1, okay? Those are bit values, okay? Here is a bit to decimal conversion. Not conversion really, just to let you know. What this really means right here, see this one, it's really 1, 2, 3, 4, 5, 6, 7, 8. You see? 1, 2, 3, 4, 5, 6, 7, 8. So this 1 means that the 1 right here is on. So that's why it's 128. This one here is 1, 2, 3, 4, 5, 6, 7, 8. That means this one and this one is on. That's going to be 192. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6, 7. 1. And then 1, 2, 3, 4, 5, 6, 7, 8. Now this table works for consecutive numbers. For consecutive. So this can help you depending on the numbers that they give you. Decimal numbers, you can convert them to binary and then to hex. Okay? This is a table you should memorize. 1 bit, 128, 2 bit, 192, 3 bit, 224, and so forth. Now it's going to help you for these conversions, which again, as part of the CCNA, it's not going to happen. They're not going to ask you to convert. I've yet to see any of my students that have any kind of binary hexadecimal conversion. I know some people out there, I guess they're for the computer science degrees, they're asked to do conversions, but as far as the CCNA is concerned, no conversion. It is in the book. We do need to teach it to you, but as far as the certification, there is zero questions on conversions. Okay? Alright, so make sure you write this down, pause the video, write this table down, and commit it to memory. It's going to make life a whole lot easier for you. Trust me. Let me go ahead and erase that. Okay? So we got the bit values on top, and we have the bit to decimal table right here. Okay, now the other one we should know. The other one is our hex table, which I forgot 0. 0's up here, okay? So nobody says, hey, look, he forgot 0. It starts with 0, I ran out of space. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then of course we start from A, B, C, D, E, and F. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. That's just the way it is. One of the things I've been getting comments, not so very nice, but do not go crazy, especially people that are going towards the certification. If you're going to be a computer science major, if you're going to go to MIT, well, hey, then, find out the whys at that point. But this is what it is. Why is A10? Because it is. Why is B10? B11? Because it is. Don't go crazy. If you're starting for the CCNA certification, don't go insane. It is what it is. There's a table to help you out. Okay? Now remember, it does start with 0. I forgot to put it. But just in case it's bothering somebody and they just can't focus because it's not there, let me go ahead. I'll put the 1 in blue right here, and I'll put a 0 right there. Just in case for those that really get confused because it's not on the table. Okay? Alright, so let's start with a simple decimal number, right? Now again, I'm going to use it, numbers between 0 to 255. So let's use green. And let's do a number like 227, let's say. Right? So you have a decimal, 227, that they want you to convert to binary and hex, or just to hex. You always turn everything to binary first. Binary is always your middle ground. So you got 227. Hey, look, this is where this table comes in handy. Alright? So if 3 bits, okay, so we got 1, I'll do it up here so you can see. 1, 2, 3. If you add these 3, you get 224. we need to 27. So how many more bits we need to turn on? Well, the 1 and the 2. Because if these 3 consecutive equals 224, by turning these 2 on, that's 3 more, correct? That will give us 227. And then all these are off. So the binary for 227 is 1, 2, 3, 1, 2, 3, 1, 1. Alright? And that's how you use this, this table. Alright, now, we need to convert this to a hex number. Remember, each hex number is 4 bits long. So, 1, 2, 3, 4, line. 1, 2, 3, 4. Okay? What are their bit values? 1, 2, 4, 8. 1, 2, 4, 8. Why am I not using this? Because the highest bit value here is 15. So I can't go past that. So I'll use this. So you add the ones that are on. So 8 and 2 is 10. 4 is 14. And 2 and 1 is 3. Okay, so what's 14? 14 is E. So E and 3 is 3. So what do you have? We went from the decimal 227. We converted it into the binary format. Alright, and from binary we separated into 2 sets of 4, and then added the bit values that were on, and we came up with E3. That's as hard as it gets. Okay? I'm going to do another one. Alright, so we'll go from decimal to hex, and always taking it to binary, because that's our middle ground. But again, pause the video. Alright, take a look what I did. Again, I took this decimal, I turned on the bits that gives me 227, broke it up into 4-bit chunks, added the bit values that are on, and that's how I came up with the E3. Okay? Again, using my tables. Alright, let's do another example. Not so easy, so, you know, it's out. Well, he's using the table. Of course it's going to be easy. Okay? So let's go ahead and, I don't know, let's say 56. Is that a hex number? Is 56 a hex number? No, it's not. For those of you who said yes. In order for it to be a hex number, we need to see that 0x in front of it. All that does is to identify that what we're looking at is a hex number. Because if you see this, that's a decimal. The decimal 56. Oh, but if you see a 0x in front of it, oh, that's the 56. Alright? 56. Okay. So let's go ahead and convert 56 first to binary, middle ground, then to hex. So 5. Right? We need to convert that, our 56. Oh, I'm sorry. Totally backwards. I said I was going to do a decimal, didn't I? Yep, sure did. Alright, lack of carbs. Alright, so 56 the decimal. Let's erase that up there. And this is where we use this up here. Okay? So what bit values can we turn on to get to 56? Well, we definitely can't turn on these two because that's above, right? So we turn on 32. Right? Well, not enough. We still need to keep turning on, right? Well, what's 32 and 16? That's 48. Now we got 48. How many more do we need to get to 56? 8 more, right? There you go. Now, so now the binary for 56 is 1, 2, 3, 1, 2, 3. And let's just verify, 32 and 16 is 48, plus 8 more, right, we're adding, is 16. So we turned on the bit values that actually gave us 56. Alright. So now again, we break it up into sections of 4. So 1, 2, 3, 4, line, 1, 2, 3, 4. Hey, wait a minute, what happened over here? We have nothing, so well, they're just zeros. Zeros to the left don't count. Alright, bit values. Alright, so we added them on. So these two bit values are on. That's 3. only this bit value is on, and that's 8. So the hex number would be 0x38. 0x38. We went from the decimal. Ooh, let me be a little bit more. Doesn't look too good there. My handwriting is not the best in the world. Thank God for computers. This is the decimal 56 that we converted to the binary of 111000. And of course, the bit values to the left don't count, so the zeros to the left don't count. All right? And then we broke it up into sections of 4, and then we just added the bit values around. So on this side is 3, and on this side is 8. So the hex will be 38. 38. Okay, we'll do one more example, an easy example. Again, another decimal. I think when you're having issues, just pause the video and just go over it. Okay, just go over it. And you can verify all this just by using the calculator that you have to verify. Okay, don't get accustomed to using the calculators because, like I said, when you go actually take your certification, they do not allow you for calculators in there. Okay, all right. So let's go ahead and pick a number. I don't know. Let's pick one. So I really don't feel like adding that much. Let's pick 250. All right, the number 250. So again, we can use this table in this case, right? So we have 5 consecutive bits that are on. That gives us 248. So it means we have this one, this one, this one, this one, and that one. All these, if you were to add these bit values, will give you 248. Now, I said 250. So how many more we need? We have 248. We need 2 more. So we turn that one on. So now we have this. Okay? Now we have that. So the binary for this guy is 1, 2, 3, 4, 5. Okay? That's the binary. Now, how do we go from there to the hex? 1, 2, 3, 4. Line. 1, 2, 3, 4. What are the bit values? 1, 2, 4, 8. 1, 2, 4, 8. So you add these two right here. 8 and 2 is 10. And all these equal to 15. So this is 15. Now we go to our handy dandy hex table that starts at 0. Okay? So 15 is F. And 10 is A. So there you go. 250 is FA in hex. Okay? I mean, that's it. That's the gist of it. Now I'm going to show you if they give you a larger number than 255. If they do, they're just not being nice. Okay? But this is what you would do. Now you see that I stopped at 128, right? I just kept, doubling as I went, and I stopped at 128. Alright, because it's 8 bits in 1 byte, and usually we don't go over that. But some instructors, professors, they like to, show off a little bit. What if you have a bigger number? Well, let's say you have a number like 600. Well, you stopped at 128. Even if you add all these on, you're only going to get to 55. So you got to keep going. So after 128, right, you got 256. Now I'm going to wrap around, all right? Like if it was doubling, but I'm going to wrap around. So then you got 256, 512, 1024. Oh, that's it. I can't go because I'm trying to look for 600. So the bit value of 512 needs to be on. So this guy needs to be on, right? So how many more do I need? Well, here, let's use a little different method. 512. Let me subtract from 600. This would be 5, 9, and 10. I need 8. I need 88 more. So this one's on. This one's off. Too much. This one's off. Too much. Turn that one on. Lovely. 64. That leaves me with 24. Too much. 16. That is 8, and then 8. Then the rest are 0. So basically what I did is, I kept going. I didn't stop. I went 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Can't start there. That's a lot bigger than 600. So I turned on the 512. But then how many more do I need? Well, let me subtract 512 from 600. That leaves me with 88. So then I said, okay, well, what number can I subtract from 88? Well, 64. Then my remainder was 24. Well, not 32, then 16. And then my left was 8. So I keep subtracting. Alright? So now I have the ones that are on. So let me erase that because I got a little board, soon to get a bigger board. Alright, so now I know the bit value starting from 512, that's 1, 0, right? 1, 0, 0, 1, 0, 1, 1, 0, 0, 0. And you can see there's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. You see that? Now, we have to separate. Now, this is your binary. That's how the binary would look for that 600, okay? So, now let's put it into sections of 4. 1, 2, 3, 4, line. 1, 2, 3, 4, line. 1, 2, 3, 4. Again, if you only have 2 here, if you only have 2 there, well, put 2 more, put zeros on there. Bit values. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Alright, so what's on here? The 2. What's on here? The 4 and the 1. And what's on here? The 8. So, the hex value for 600 is 0x258. That's it. Always take it to binary. You go from your decimal, you turn it to binary, and then in binary, you separate into sections of 4. Find out the ones that are on, put them down, and that's it. If they go above 9, then you have the A is 10 and B is 11. So if this would have been 12 or 13, whatever it comes out to, you can find here and put the letter value. But again, if it's a decimal, find out the binary and then go to the hex. Alright, that's that one. Let's say they give you an actual hex number. Well, have we done that? Let's see if they give you a binary number. Okay? We've done hexadecimal before, you guys have seen the video. Okay? But let's say they give you an actual binary number. And I'm not going to go above 255 on this one. Alright? It's the same concept, just do it over and over and over again. So now we have, let's say, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So they give you this binary and say, well, what does not, in the CCNA certification, one of the ones that I did like over 3 years ago or more, one of the things that they do for one of my retakes was give you IP addresses in binary. And then they asked you, is this a private or a public, and what class it is, and all that kind of stuff. But again, lately, from my actual students where I teach, they very little subnetting, very little IP addressing, but they kind of sneaky because they bring it in as far as in OSPF with a wildcard mask and all that. So they'll sneak it in there, but in a different way, not straightforward. Okay, so you still got to know it. But anyway, so you got this binary number. How do you convert that to a decimal? Well, the bit values. Okay, so this is a bit value of 1, 2, 4, 8, 16, 32, 64, 128, right? Your little table up here. So 128 and 64 is what? If you don't want to add it, go right here. So this is 192. So then 192 and 16 is 208. Okay, and then you add the 8, that's 16, and then you add the 1, 217. So the decimal value of this number is 217. All you gotta do is just add the bit values. That's it. Now, you want to find out the hex? Same principle that we did before. Okay? We'll go ahead, separate this into chunks of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4, 8. 1, 2, 4, 8. These two are on. That's 12, right? 9, 10, 11, 12. This is 12. And this is 8 and 1 is 9. So what's 12? C. So C and 9 is 9. C9. So the hex for this binary is C9 and the decimal is 217. For those of you guys that, you know, this is base 2. This is those for you with PhDs and masters and all that. Base 2, base 10, base 16. Okay? Hex, decimal, and binary. Alright? That's it. Basically, you go from your decimal to your binary to your hex, or from your hex to your binary to your decimal. Remember these tables, your tables right here, your bit values, and the bit to decimal. If you're going to take a test, one of the first things, whether it's a certification test or just a test in school, always write down these tables. Do not forget it before you begin doing anything. Write down your tables. That way, all you need to do is just point to what you're doing. Okay? Point. And just be careful in the adding or subtracting. Alright guys, that's it. That's as hard as it is. Always remember, like I said before, write this down before you start a test. And by the way, go to the site, thenetworkingdoctors.com for the new upcoming webinars, okay? And if you're interested, just register.